Okay.
Thank you.
Thank you. Good morning, everyone. So I'll start with today's session now. So all members can open the slide here. It is in the folder of code level 2 internship. So Python ML algorithm. So this is the slide. So today's session, the first session, it will be completely with the theoretical part, where I'll be starting explaining about the algorithms. So we'll see like internally on what concept these algorithms are developed. Okay. So in the yesterday's sessions, we saw with respect to the machine learning, two good examples. We saw one was the loan prediction, and another one was the customer segmentations. In those all codes, we use some algorithms, right? What are the algorithms we used over there? Can anyone of you tell the name of it?
SVM.
We used SVM, right?
KNN, SVM.
And one more was? One more algorithm was?
Navy base.
No.
Logic regression, KNN, and
Yeah, logistic regression, KNN and SVM, right? Okay. In the loan prediction, I first explained about only one algorithm, that was the logistic regression. And in the customer segmentation, I used all the three algorithms, SVM, support vector machine, KNN, K nearest neighbor, and then logistic regression. See, if, we learned first how to use the algorithms. For these algorithms, are there in which library, how to access it, how to pass your training data, because we were supposed to understand the full cycle of machine learning. Okay. So as we studied machine learning in the initial sessions in the day 1 and 2, like with respect to the theories, so that practically we were supposed to see it. Okay. We were telling like in the day 1 class, like machine learning, it is like adding intelligence, getting data to the, giving data, collecting a lot of data. So we saw that in a practical way, what is the meaning of data, how it looks, and how that can be processed in a right format so that it can be passed to some algorithm, and while passing that training, testing. So all those procedures we saw, right? So we used how to start off writing a machine learning code, and we made use of those algorithms, right? Now, algorithms means what? So it's something, a concept or with some set of protocols or set of theories which involves a lot of statistics, mathematical formulas. Based on some procedures, it is developed. Okay. And it will be quite generalized. It is not specific. Whatever the code we are developing, that is specific. Now my code was there, right? For loan prediction. Suddenly, if I say change the data set, few lines I have to change in my code, right? So these kind of codes are called as an application codes, where it is done specifically for some specific of end user requirement. Okay. When you get into the backend development, so in backend development, a lot of things will come. If you go in deep, like when I started off speaking about Python programming, I told a statement like the Python programming language is developed with C program. Okay. So means what? So Python is a language. So somewhere, see, in computer, whatever works for that, some coding method has to be there, right? So the Python itself is developed with some C program. So C programs are used on a maximum end with respect to the backend developments. Okay, it is more on analysis. Clear? So same way, even the algorithm comes on the backend. So when you get into the operating system, we use the word called device drivers, kernels, and all. So those all acts as a backend codes. So those codes are writing is really tough, because we have to write that code in a very generalized format. See, we use logistic regression in both the applications. In my loan prediction code also I used, and I used in another one with the customer segmentation. The algorithm is such a generalized way. See, when I pass loan data also, it started off giving some reply. When I pass data related to customer segmentation, it was giving a reply. So backend codes, always it will be completely in a very generalized format, and becoming a backend developer, it comes within a lot of domains. Okay, I'm speaking in a very general format, a creamy layer of it I'm just discussing now. So just to make to understand like what algorithm is not a simple word, and very easily with the basics knowledge we can't get into the algorithm developments. Okay, algorithm development life cycle is totally different. So which is a part of a backend development. Like we tell device drivers programmers, kernel programmers, and also this is not an easiest task because application programmers, the concepts we hear in our day-to-day life, like loan, we know some basics knowledge about it, right? But when you get into the algorithms, when you get into mathematics and all, we have learned with the mathematics in our right from our lower education till we complete our degree level. We use mathematics, but practically usage of it is very tough. Even our additions and simple multiplications, we won't do it manually, right? So the life cycle is totally different. So algorithm part is not that easy, right? Developing from scratch. Okay, so now we'll see like in a simple way how these algorithms works. Basically, machine learning we learned like it is a type of supervised, unsupervised, and reinforcement, right? So supervised means which will be having a standard output class or a label name. In unsupervised, that part we won't get it. We won't get any output class or a label. Okay. So this is the first algorithm which I am going to explain now. See, I am not going in depth of any algorithm in this session. Just we are trying to see some 4 to 5 points about the algorithm, just to get a simple idea like how the algorithms are done internally, that too with a theoretical statement. I am not touching any formulas part and all, just some 4 or 5 lines which I got in internet as a beginner, how we can see those algorithms. Okay, so that part I am covering now. So in this slide, some 4 to 5 different algorithm names I have taken and I will be discussing in this session now. Okay, okay. So the first one is the logistic regression. So we can see here some statements which I have mentioned. So logistic regression is one of the member of a supervised classification algorithm. Okay, so it comes under supervised classification. See, one more topic I left it that in the next session I'll discuss. Basically, when we tell supervised machine learning algorithm, in that 2 types are there. One is classification and another one is regression. Okay, so what is the meaning of regression? I didn't discuss that. We'll see later. Here the name tells like logistic regression. Okay, but it is not a type of regression. It is a type of a classification only. So classification means again supervised classification. Classification means you are going to group it. You are going to classify it into with respect to the class, the data what you have, that we are going to classify with respect to the output class. So logistic regression is a type of a supervised machine learning algorithm which comes under classification. So in logistic regression, since it is a supervised, again the input parameters and output parameters comes into picture. So the algorithm basically works with some sigmoid concept. Okay, sigmoid functions. Sigmoid is one again a mathematical theoretical term. So with respect to that concept, it's going to handle. Means the algorithm is developed with the main reference of keeping some sigmoid related activities. Like that we can consider it. Now the input parameters we saw, right? A lot of data we saw with the input parameters. Based on the sigmoid concept with respect to its own formula, theories and all, these input parameters are processed with the algorithm brain and it's going to come out with the output class predictions like it is 0 or 1. So since it is represented as 0 or 1, this algorithm on a maximum way, the logistic regression will be used for the binary classification we tell. Binary means again 0 or 1. When you have the probability to detect like in the output class yes or no, true or false, any 2 stages. Okay, so it is an apple or a mango, fruit or not, animal or not, cat or dog. So when you have the classification in this format into like 2 stages in the output, 2 classes or 2 labels, then logistic regression is preferred. So here generally the variables and all the variables means again with the features, parameters what we use, right, for the data. So we call like independent variables and dependent variables. All the input features are used with the word independent variables. Again with the output features are used with the dependent variables. So when you go reading about theories and all, these are the words used over there. So the input variables are referred with X. So same thing I used also in my code, like all the input data I put it in a variable X and output I mentioned in the variable Y. This is a simple method of writing program wherever you see in internet and all. The similar formats you get it. So just I followed the same methods over there. Okay. So here some Just a moment. Right. So the sigmoid curve and all you can see here. Again with the graph it is mentioned, the curve part. So what are your dependent variables are there? Based on that, the output is classified into any two stage like output 0 or 1. Okay, so it goes with some sigmoid curve theory concepts. Now we get two types of again with this logistic regression. One is the linear regression and another one is the logistic regression. Okay, linear regression applications is different. Again, logistic regression is different. So I'll just take one example here. If you consider a data is related to some individual person details where you want to predict with respect to the marriage concept. Okay, now you have a data like with independent variables, that is the input parameters. You consider like you have a data with the age, sex, family, type of family, or we can consider religion and all. And then job, salaries, friends. See, these are the concepts which are important for to come out with the results of the marriage process, right? So now assume these all are the input parameters. So it is printed in an Excel with in the column format. The age, all these details are there with the individual person who applied for some marriage bureau that we can consider. Nowadays, a lot of online concepts are there, right? So with that, so with this data, I want to predict like which year the marriage will happen. Assume that the output class I have like the marriage will happen in within 1 year or in 2 years or in 3 years, 4 years, like that. So there are different classes I have in which year the marriage will happen based on these conditions. Okay. So very easily, if I start off thinking, assume like the salary is mentioned, his age is around some 25. Okay, so then salary is mentioned around 10,000. So generally that salary is very less and age is also very low. So still is having a time for marriage. So we can predict the output can be with the process of around next 3 to 4 years, the marriage will happen like that, right? So now age is almost around 30 plus and salaries are very fine. So he's having more than 50K, 1 lakh. So in that case, means then we can predict like within 1 year. So I'm just taking a simple example. There are a lot of other parameters comes into picture when you take it to the real time level. So just as an example, I'm considering with these two parameters. So these all we call like age and salary acts as a very prominent parameters, right? So the parameters or the features weightage is more. The dependency on these features are really more over there, right? Okay. So like this, when you have these kind of parameters and the output class which you want to predict, it comes with multiple stages. Okay, like the class can be like within 1 year, 1 to 2 years, 3 years, 5 years in that case and all. Then you can take it into the concept of a linear regression. Okay, so now the same data set I have. Okay, the same data you collected. Okay, now your company is a marriage bureau or something. Now you collected the person who comes to join you for a marriage process. You will take all his personal details, right? So that data, same data you have collected now. Now you want to predict with the same data like the marriage is going to happen or not. So that you have to take some decision like he will marry or not or something. The marriage will happen or not. Then the whole process is different, right? So to detect that marriage will happen or not, then that's a whole information we have to check it out. Like here, instead of friends, if I mention bad habits, like okay, so if he's having a very bad habits and age is almost now 50 years, so the marriage happening reasons are very less. In that case, you can consider, right? So in that format, where you want to predict like yes or no, marriage happens or not. So in that case and all, we can get it into the algorithm logistic regression. Okay, the same thing. See here also I have mentioned some of the points, so all of you can just go through it. So here, see, a lot of data sets comes in internet. It's available. Kaggle is the one website where we get all the data sets there. Like I'll show you how to get into the data set. Any data set, if you want to work practically, like you can type like loan, right? A loan prediction data set. If you give, so this is one standard website where we take a lot of data to work with the machine learning concepts. So you get a data set here. So a lot of types of data sets will be available. So whichever you want to search, normally we search in Google and we get into this website to collect the data. It can be in the image format or with the Excel data. So maximum of the projects which I work, all the data I collect from that website only. Okay. So here now, since I'm speaking about theory about these algorithms, few data set names and all I'll be considering. So this is one data set related to the vehicle. So all these data sets you may find in some YouTube videos, explanations and all. From there only I have taken some of the contents. So where for a beginner or when we are learning the concepts, okay, we have to take simple data sets, right? These all we can consider as a simple data sets which can be considered like a small mini projects kind of thing. So easy to understand. It don't come with much more complications, so that we can concentrate on learning with the concept. Okay, so we get one SUV vehicle related data set. These data sets looks in this format. Again, based on the salary, age, gender, and all the purchase of the vehicle, you can see that. So this is the output class. Like 0 means they tough to purchase, 1 means they can purchase, right? So here also like data cleaning. If you feel any of the parameter you don't want to use for your application, like gender, again to purchase a vehicle, gender doesn't matter. So your salaries comes with a priority. If you have a money, you can purchase it. So in that case, and all this parameter you can avoid for your analysis. So in that format, we can make use. So this data set is named like social network ads related. If you search with this name, you can download that data set from internet. So purchase related activities, all these things can be handled with the logistic regression. So logistic regressions result is like binary format. Already I discussed about these things, and here maximum outputs will be in the format of yes, no, true, false, high, low, pass or fail, like that. Okay. If you had observed my first data set, like my first code which I explained loan prediction, even our output was in the same class, like yes or no, right? So it predicted fine. No? But when we get into the second example, customer segmentation, there the output class was 4. But as per theory, here we are seeing like logistic regression, maximum it is used in the binary format when you have only 2 class, like yes or no, true or false, high, low, like that, right? But there we were supposed to classify the segment like the customer belongs to the segment A, B or C or D. There also I use logistic regression. See, what it means is any algorithm, that's what I told in the beginning today, like algorithms are done in such a general format. If you give your data, it won't tell like, no, I can't use this, I don't know. It's not like that, or it generates some errors and all. So as per that data, whatever the way it can predict, it predicts it. Okay. Like assume you know some 3 to 4 friends. One person is very good with the cricket information. So that is his experience. The way of speaking about the sports and all is very good. One person is good with the mathematics. So you know the persons, right? So when you have some questions related to mathematics for whom you have to ask, you know that you'll ask for them. And one person is good with average of mathematics, average of cricket, even he can also answer. So same way we have to pick up our algorithms, understanding like on which area this is much better. Okay. With respect to our input, we have to pick up the algorithms, our input and output. Like here I explained like 2 types of outputs. You want to predict the data is same, the input parameters are same, but you want to predict like in which year the marriage happens, that output category is different, and he will marry or not, the marriage process happens or not. So that kind of output category is different, right? But the input parameters are almost similar. But which parameter gives better weightage, which is having higher relevance related to that output, that we have to decide in the pre-processing stages in the program. Then select the suitable algorithms and pass your data for them. And all these algorithms can be configured also. That yesterday I showed in the internet, any algorithm name you can give in the net. So it can be configured. Okay. So now we'll get into the next algorithm, KNN, K nearest neighbor. So a few points has been mentioned here. So all of you can just go through it once. So here you can find some ball related images. Few points has been mentioned here. Just go through with that. I'll start the explanation. Okay, so the next algorithm is KNN, K nearest neighbor. Okay, now we'll see like how this algorithm works on what concept. A few points we'll try to observe related to this algorithm. The first thing is normally in the beginning stage we just confuse with the KNN means near like neural network and all, because NN is a short form generally used for all the neural network related algorithm names and all, but it is nothing related with the neural network. The KNN works with a different concept. Okay, so the second thing is it is a type of again with the supervised machine learning algorithm. So you can read the statement here. K nearest neighbors algorithm works in a way that a new data point is assigned to a neighboring group. It is almost similar to. See here you are finding these dots, right? All these dots are called as a data points. Like one row, what we saw in that example, right? In the Excel, one row, that is one data. Like when I use the word fruits, apple. So here each dot is a information related to that apple. So in a graphical format, the data are explained in this way. Okay. Now you can consider this is already a grouping has been done or a clustering has been done. This image, what it refers like now, one type of data we have, which is a type of a blue color. So this is another cluster. This is another cluster. Like that it is with the image. Okay. So now we'll see like now the training has been done for the KNN, and if you want to give your new data to test it and your test to classify belongs to the red type of data or blue type or a green type means, then how it works, the KNN, K nearest neighbor algorithm works in a way that new data point, the new data which I pass for testing to the algorithm is assigned to a neighboring group. So this is the group, right? So if you consider a new data point, so that will be assigned to the neighboring group. Neighbor means which is very near. So neighbors we tell, no? Which is nearest group. So it is the new data point is assigned to a neighboring group. It is almost similar to, means the features which is almost similar. So the based on that, it's going to assign to the nearest group, that is the neighbor group. So now how this works? So that is a simple statement of KNN. So normally the new data, whenever it enters into the testing after training, now you have passed your data for training. So internally the algorithm based on the output class, here the class was 3. According to that, it has made some decisions observing those parameters. Now when you pass your new data, that is the testing data. So that data it is going to assign with the neighboring group based on some feature matching. Clear? Now in K nearest neighbor, K can be an integer greater than 1. So here K is one parameter kind of thing for the KNN algorithm, where it has to be an integer and greater than 1. So minimum 1 has to be there. So greater than 1. Okay. So for every new data point we want to classify, we compute on which neighboring group it is close to. So the new data point, for every time whenever we want to check with the new data point, means new testing data, we will compute and find out the neighboring group it is closest to. So here we came to know the second point in KNN is that K is one parameter which has to be greater than 1. Now we'll see here. So there is an example of related to the ball kind of thing. Just with the picture image, we can observe like this is a football, volleyball, and tennis ball is there. So you can see like with respect to the cost and durability, means the life of that ball. The way if you start off using all these ball for a month, regularly you are using on the ground, so which is much more durable. So in a longer period, which ball you can use. So based on the durability and the cost, you can see this graph. See, understanding the graphical view also is very important in machine learning, because by observing these graphs, we have to collect the data. Okay, means we have to collect the right information. So how this graph refers is like I'm just explaining about the graph, the image, this one, okay, graphical image part. So the as the derivative means here what we can understand is the footballs and all, the cost also is quite better only, means it is not low price also, it's not with very high price also, it is having some medium price kind of thing, and the derivative of the footballs are very less compared to these two, right? Because see the derivative as it goes in this direction from left to right, it increases, and cost from bottom to top, it's going to increase. If you are considering in that format, the football is something where the derivative is very less compared to other two class, and the cost is also not in a less price. So if you see this tennis balls and all, the cost is better compared to a football. These are cheaper also, and the derivative also is quite good, right? So the derivative is better than the football. The cost is also low, and derivative is better. Now you have some more data. Each data you are having, no, that is the information here. Okay. So some more data we have like related to the basketball, where basketball is expensive compared to other two balls, and the durability also is good. The life of the basketball also is very good. So now here a few more points are there. You can just see that let k is equal to 5. So k is assume 5. We'll see like what's the meaning of it. So these glowing ones are the closest 5 balls. So that I'll explain. There are 3 tennis balls and 1. Okay, those will classify. Okay, so now we understood a little bit about this graph, right? Now, see, you have passed this data to the algorithm now. Each ball information is a training data. So that training data I passed to the algorithm. When I was explaining, always I was taking an example of a fruit, right? So you can consider apple. Apple is always expensive kind of thing. Mango, the cost is also fine, and the derivative very fast it gets spoiled. Like that you can think. And one more was orange. Orange costs also less, and the life also is good. Means you can keep it for 1 week of using it. So like that you can consider. So this one is an apple, this is a mango, and this is an orange. So similar way, the data are there with respect to the ball. Now you got a due. So by passing these data, the algorithm is trained. Okay. Now how the algorithm works? See, whenever we are using KNN algorithm, explicitly means in our program we can mention one parameter, that is the k value. You can mention what should be the k value. Like here in this example, it is taken as 5. But we use KNN in our example also, right, for customer segmentation. But there I didn't mention any k value at all. So if you are not mentioning k value, the algorithm goes with its own default values. So that is the main thing about Python. We saw in the functions when I explained about Python programming functions and all. So parameters, maximum of the parameters in Python libraries, it is assigned with some default values. Okay. If you want to explicitly mention any specific value for your parameters, you mention it. Otherwise, it works with its own default values. Clear? Wherever compulsory, like user has to give, user means when the programmer has to give his parameter, means that time it is not initialized in those libraries. So where it will pop up an error like here some parameter data are missing. So that time we have to understand that function and we have to mention those required values. So here when we called our KNN, we didn't configure anything, means we didn't pass any our own specific parameter values and all. So whatever the default was there, it worked. Now we'll get back to the theory of it. So here the k value is assigned 5. What it means? See, this is a new data point. The black color one you are finding now. This is the test data. So this data, I don't know it belongs to which class. So that's why it is represented with a black color. Means it belongs to football or a volleyball, basketball or a tennis ball. We don't know that one. It's a new data, right? So this data, now our algorithm has to analyze and it has to tell like it belongs to which class out of these 3. So how it starts of analyzing is the way KNN works is it is taking the k value in its mind. So here the k value is assigned 5 means from keeping this data point, it is going to draw a circle in such a way that circle with some radius measurement, it has to cover 5 data inside that. The meaning of k is it has to cover the nearest neighbors where it comes with a 5 data. So you can see here. So these glowing ones are the closest 5 balls of our new data point. For this new data point, the nearest neighbor So it's going to take some nearest neighbors, keeping the reference as the 5 neighbors it has to cover. Okay. So now the one circle has been drawn. So in this one, we are finding like here, there are 3 tennis balls and 1 each of basket and football ball. So when the circle is drawn, okay, for a nearest neighbor, keeping a condition that 5 has to be covered over there. Okay. So 5 neighbors are covered. Then it starts off analyzing. So it got like 3 neighbors with the tennis and 1 with the basket and 1 with the football. Right. So since more neighbors are there with this tennis ball, this data point it will assign to the tennis ball. So the new data point means the test data which you are given, right? That will be classified like this ball, the new ball when you give to the kid, when you give to the algorithm, by observing the features. How it is observing? It is going with its own theory with the KNN method, taking K value as 5. The nearest neighbors it's going to check, and in nearest neighbors it has to cover 5 data. So in that 5 data, it finded like a 3 are maximum with the tennis ball. So that new data point it's going to assign as a tennis ball. So for the new data point or the test data which you passed, it is classifying it as a tennis ball. So the classification or a labeling has been done. Clear? Now assume like while drawing this one, instead of 5, normally here K value has to be mentioned with odd even, that also comes into picture. Just take an example. Okay. Now here I mentioned 6, and all the data point is such a way when you draw a circle of 6 data, all 3 categories are repeated with the 2 balls. Okay. So that time again it will apply some theories and it works. And algorithm doesn't works in one shot. It's not like it just took 5. Internally it goes with the multiple cycles. This is just understanding the algorithm in a very outer layer, in a creamy layer. Okay. So n number of cycles are formed with the algorithm when it works internally. But a simple statement, if you want to tell about KNN, someone asks, speak about KNN with the 2 points or 3 points, that point I'm speaking here. Okay. Just as a outer layer of it. Internally, it works with the n number of process and n number of cycles. Clear? So when similar data points are found, like assume like a 2 tennis ball it finded and 2 basketball and 1 football. So that time 2 data points came similar, right? Like 2, 2 and also in that case, again, it will read out this K value by changing internally with some other numbers, and it's going to check it out. Fine. So in that way, the KNN works and it comes with some final decisions with the final classification. Okay, so with this, I completed the KNN algorithm. So we saw the example of 2 algorithms. So till now, whatever I explained, any doubts are there, you can just clarify. See, the knowledge of these algorithms, even I have with only with the basics levels. I'm not going in depth about it because basically I am also an application developer where I make use of these libraries and I come out with some end results. I'm not into any core architecture level development activities. So few points I know about these things. So any doubts if you have, you can just clarify. I'll just wait for some 2 minutes and I'll continue with the next algorithm. Any doubts? Okay, so now I'll continue the next topic. Sorry, next algorithm. Okay, so the next one is the Navy bias, Gaussian Navy bias. See the algorithms, the names which I am explaining, all these are some standard algorithms. A lot of examples and applications we can find with respect to these algorithms. So in and I have made a list in such a way like each algorithm, the theoretical way the algorithm is described are quite different. So those points only I'm just covering it. Okay. So here few points I have mentioned on Gaussian Navy bias. So all members can just go through with that once. Okay. So when we get into Gaussian Naive bias, there are three type of naive bias models. So we get Gaussian multinomial and Bernoulli like that. So what we can understand this is again naive bias is classified into three categories. Means the algorithm only we can type three types of algorithms under naive bias, right? So naive bias, it works with something called as a bias theorem. So again, it is with the mathematics part. So this naive bias is designed in the algorithm is designed using some bias theorem method. Okay. So what is bias theorems and all? We won't get into that one now. So few points I'm just covering it. So what's the meaning of Gaussian? Again, Gaussian also is a mathematical term. With that, some statements will come into picture. So based on that also, these algorithms are designed. So naive bias, so basically some bias theorem is there. Then some concepts of Gaussian also has been used. So here, whenever we start up searching in internet with respect to the Gaussian with respect to the Navy bias algorithm, we find this formula. Okay. So basically it handles the things with some probability. The method of probability will be used over there. So here some A, B and all is been mentioned. We'll see like what it is, all those things. Okay. So we get one more data set in internet with a medical term like breast cancers related. Again, this data set is in the Excel format only. For all these algorithms, I'm considering the data in the Excel, means with the numerical and integer strings format. So whenever you see this data set, you get these parameters like the data set is having 569 instance, means that many rows, that many data. So 560 plus data is there, and it comes with 30 attributes of features. So that is the column. Okay, so 30 based on that tumor, the radius of the tumor, texture, smoothness. So some parameters will be there with respect to the tumor. So this is one more data set generally used in internet to explain different algorithms or different concepts. These are all very basic data sets. Okay. So where it is having some 30 parameters, using that parameters, you can apply your algorithm to work. Gaussian Navy bias right now, as per internet information, I have seen like it is used in Gmail for spam mail classification. Okay, like you want to predict the mail is a spam or not. So these things we are seeing, right? Some 6-7 years back, who are used Google and all, spam mail detections and all was not happening correctly. So later we have seen that one. I think at least 8 years back, that spam mail method was not there. So now Google made one more category like spam detections and all, like unwanted mails. Basically for the marketing peoples and all, they'll be sending a group of mails, bunch of mails in their network for marketing purpose. So that is not the really information required for us. Okay, because a lot of junk mails comes when the marketing people starts of sending on it. and some theft related activities also are handled with these spam mails. So the Google decided like it has to segregate that as a separate way. Right. So whenever you receive a mail, the Google algorithm works in such a way it is already trained with the spam mails. So when the new mail comes, it's going to check that it's with older trained training data related, that any spam information has been got or not. So according to that, applying the Navy Bayes theorem, so the formula based on that one and all, Navy Bayes algorithm, it's going to predict like the mail is a spam or not. So it works with that concept. So this is the one which I found in internet. Many places when they are explaining, they are taking a spam mail example for the Navy Bayes algorithm. So one more condition, like now cricket matches and all is there. This is another examples. Okay, real-time examples I am taking now, which I found in the net. Basically, when Navy Bayes concept is explained, that time I am finding these kind of examples. Okay, so one more example with the Navy Bayes. Okay, so where cricket related to that, now we want to make select one day like the next month. February 25th, I can conduct a cricket match or not on that day. So you have to make the timetable of it, right? The next, like from April, IPL will start. So which all days the match has to be conducted. There are many other reasons also, like normally Sundays, if you are keeping some prominent matches, many people can watch. This is one input, right? And with our general knowledge, we can tell that one, right? So similar way, based on the weather conditions, we don't know like in April what will be the weather conditions, right? One general information we have like summer, rainy season, winter season and all. So how we have the data in our brain, according to that we can tell like, okay, April month it will be a summer season, you may get a little bit rain, that is and all we can tell. So same way the algorithm also will be having a training data. So when you get into the computer, so the training data will be there with respect to the weather conditions, and we have a lot of things working with again with the machine learning, where it's going to predict the weather conditions about the futures, like in next 2 months what will be the weather conditions, and generally regularly it will be updating. Okay, it will take real-time data of today's. Again it will cross check that the output what it predicted, assume like April 10th. Okay, for yesterday's, it has taken yesterday's weather condition and all, and April 10th has been decided. On April 10th, we'll be having these kind of weather conditions. Now again, today we got the real-time parameter, right? Today's weather condition. I'm speaking about Bangalore, you consider. Okay, today I got the today's weather condition. Again, my algorithm works with the today's new data also, and it will cross-check that whatever the decision it took yesterday, that is correct or not. Again, with respect to the new data which it received. So daily, this all we call it as a time prediction based algorithms, where the things works with the real time. You are predicting about the next month what is going to happen, but daily you are going to get the data about with respect to the time in a day format, right? So the similar things we get in the stock market analysis also. So in stock market, if you take one example of any company like Infosys or Wipro, so next month if you want to predict in March 10th what will happen like that, and also with some examples. There are a number of reasons are there, the quarterly results, a lot of things will be there. So yesterday we predicted like, okay, in March 10th, the Infosys share price will be of so and so value. Okay. Now, today we got the price value, right? Assume like today something came, some bad news came or some happened. So the price drastically it reduced. So due to some reason, some 10% reduced in that share value. So again with today's real-time data, that March 10th what we predicted, right, that will again rework on that. So that will, the prediction value will change. Again tomorrow some changes will happen. Assume like whatever the news came today, that was not so much valid. So tomorrow again the market will rise up of Infosys share, right? So again that will be predicted. So based on today's data, it will tell like, okay, it is with the value on March 10th, it will reach 2,000 rupees. So today it suddenly reduced 10%, right? That will be adjusted to 1,900. Tomorrow again the news came like, no, yesterday's news was fake. It is not having much weightage. So it is not the real something. So again within 1 or 2 days the market will rise. Again it will predict like, no, again the share price will be around 2,000. So this is just taking with the time predictions, right? So when you get more into time predictions, the different types of algorithms are there. When you get into this kind of weather reports, so get analyzing a weather report, weather data, and coming with some output class decisions, that is one type of machine learning. again revising that output class with the daily based on time predictions. Again, that is another type. Means the whole project will be splitted into n number of stages. It's not like if you take example of one project, it's not like it works with single algorithm. It works with multiple stages, combination of multiple algorithms based on your input and different types of output. Which all outputs are required, according to that output, different algorithms, different methods will be working. Okay. So we can see that navy bias also is used for some productions related to the play can be done or not, like that, based on the weather. So here these are the input parameters. Now we at least by seeing these things we can decide like what is the input parameter, what is the output parameter, output class, right? So as per this navy bias formula, here also that initially we saw the formula like ABC, AB like that, right? So the meaning of A and B is much written in this. Here you can see that it is class and data. Okay, so the class and data, class means that is the output for us, right? And data, that is the input. So it is going to apply some probability method for those input and output with respect to the class and data. A simple formula has been given here. So here output is referred as class, output class, and these are the input which is stored as a data. Input is considered A and output is considered C. In some formula C is used, some formula B is used. See here you can see that C has been used. Here you can see some actually the output A, they had used A, and the input they had used letter B. So don't get confused here based on these things. This is much better to understand. Okay, class and data. So in that format. So why I kept all these type of formulas is see in different explanation, different method they are using, but everything is same. At the end the formula concept is same, but A, B, somewhere C, A, C, somewhere class, data. So the way of understanding is very important. So this is with the navy bias algorithm. So the next one is the random forest. So we'll take a small break of some 5 minutes and I'll continue with the next algorithm. So meanwhile, any doubts, anything is there, you can just coordinate. Short break, I mentioned 5 minutes. So any member is having any doubts or anything, you can just clarify. So after this break, I'll just continue with the next part.
R&D proposal. Funded projects. Brief.
ಅದು ಅವಾಗ ಗುಂಡಿಗರಿದ್ದಲ್ಲಿ ಹಬ್ಬ ಇತ್ತು ಹಿಂಗಾಗಿ ಕಾಣಿಸ್ತಿಲ್ಲ.
So I'll continue with the session now. Till now, whatever we discussed, if any doubts is there, you can just clarify it. Okay, so now I'll get into the next algorithm, that is the random forest classifier. So I mentioned few points here, so all the members can just go through it once. Random forest. Some slides are there related to the random forest. You can see some terms here like decision tree, voting. Few explanation I have mentioned here. So all members can just glance these points once. So I'll continue with the explanation. I'll wait for 2 minutes and I'll continue with the explanation. If any doubts, anything is there, other members can clarify. Okay. So random forest algorithm is used for both classification and regressions. Basically, again, it's a supervised type. Right now, what all I am discussing, all these are supervised machine learning algorithms. So it can be used for both the type like classification and regression. Okay. So random forest, as the word comes with the forest. So we'll see like what it is with the algorithm name, some informations we can collect. So generally forest means it's a group of trees, right? So means when you have a huge data with lot of parameters and all, so that time to take some decisions, this algorithm will be useful. So you can see the statement here, a forest is comprised of trees. It is said that more trees it has, the more robust is the forest. Means forest, as many trees we have, it tell like it's a strong forest. Means the forest is very dense like that, right? So random forest creates a decision tree on randomly selected data samples, get predictions from each tree, and select the best solution by means of voting. So with this statement, what we can understand is basically random forest works with two concepts. So the first concept is something called as a decision tree. Okay, so random forest creates decision tree. So internally means it's not like we write code for this. Okay, when you call the algorithm, when you pass your data, okay, all your training data, when we pass internally, how the algorithm works is it's going to make something called as a decision tree. With that decision tree, with random samples, it will come with some predictions. Then it will go with something called as an voting. The whole algorithm random forest works in two stages. One, getting the decision tree, and then with the prediction result of the decision tree, it is getting into the concept of voting. So based on that, it will come with some final decision, right? So in that way, it's going to work, decision tree and voting. It also provides a pretty good indicator of the feature importance. Feature means, what is the meaning of feature? Any member?
Columns that we have.
Right. Okay. So in our data, whatever the columns we saw, right, those are called as a features, parameters, attributes, variables. All these are the similar words. See, many times I'm repeating this word because these are quite important whenever you spend time reading in internet, right? So some people in their explanation, they'll use the word features. Somewhere you'll find parameters, somewhere dimensions like that. Okay. So that's why keeping in mind is important. This is. So you can find the statement. It also provides a pretty good indicator of the feature importance. So when you have multiple features, right, to come up with the output class, which feature is giving the high weightage, which all features are giving like 1 or 2 or 3 features, giving the high weightage for the end output. Okay, which feature is more important? If you want to find that one, then you apply random forest. So in many projects, like even in our loan prediction, if you want to find out in loan prediction, we saw some parameters there, right? In those parameters, which feature is important? If you want to understand that one, then we can use random forest over there. Random forest can be used as an end prediction result also, or even it can be used for the feature importance also. So then random forest can become like an algorithm which is used in multiple projects in the pre-processing stage, because when we are getting into some pre-processing stage, we want to understand like which feature is important and which feature is not so much important, like that, right? So in that case, we can use a random forest algorithm. Clear? So that is one of the application of the random forest. Means in many projects we can find like random forest is used in the pre-processing stage also. Clear? So random forest algorithm is an ensemble classification algorithm. Ensemble classification means a group of classifiers. Why it is called as a group of classifiers means as I told before, random forest works with two stages. One is with the decision tree and voting. Decision tree itself is one algorithm. So that's why it is called random forest is a group of classifiers. So inside that there is already one algorithm, that is a decision tree classifier. So it is going to use one algorithm decision tree and then it is getting into some voting method. So now we'll see one example here to understand the random forest in much better way. So you can, I'll just read out the statements which I mentioned here. This example is related to the trip concept. Okay. So now assume like you want to go for a trip, and you would like to travel to a place which some trip we want to do it, which will give enjoy. Okay. To find the place, now where I have to go. Okay. Search online. Sorry. Right. So search online, read reviews on travel blogs and portals, or you can also ask a friend. This is the method what we have right now. You want to go to some other state, okay, like North India and all if you want to go. So generally we won't have much information about those places. So in that case, I'll be searching some travel blogs related in the online portals and all, because nowadays a lot of information we get in net also, right? And we can ask some of the friends we know, like someone have been visited that place before, means we can coordinate with them, right? So this is the method what we follow. So decided to ask friend. If you get into the point of you are going to ask a friend and talk with them about their past travel experience of various places, we'll get some recommendation from every friend. So assume like some 4-5 friends I have now. Now I will start up discussing with them. So obviously based on their interest and based on their own experience, they are going to suggest a few points for that, right? So you go in this place, visit this, that something and all, they are going to suggest. Now you have to make a list of those recommended places. So they will tell like, okay, visit this place. Now, say if I ask someone like Delhi, if I want to go, so they'll tell like you visit this place, they'll give a list of it, right? So first you go there, second here, like that, something and all, some information we get. So we have to make a list of those recommended places. Then you ask them to vote. So once we make a list of it, so we are going to ask them to vote or select one best place for the trip. So when they make a list of some 4 to 5 places, in that day I can visit any one place or something, means then you need to make a get into the voting concept. Okay. So first we made a decisions of a few places based on some parameters. Then we are entering into the voting concept, like which one is the final. The place with the highest number of votes will be your final choice of the trip. So for whichever the place we get more voting, so I'll decide like this is the final place which I have to travel. So we got this example, right? Now we'll see like how it can be explained with respect to random forest algorithm, right? So in the above decisions, we have two parts, right? So now we'll see when you pass this your travel related activity to your random forest, we got the decision with the final class, final place name, like visit this place, like that, right? So now how that works internally is so the first part, asking your friend. We asked our friend about their individual travel experience and getting recommendation out of the multiple places they visited, right? This part is called as a decision tree. So you can see one diagram here. So we have a training data, training samples. So the features of parameters, someone will tell about the food, someone will tell about the expenses of about those places. So just consider it that format. With that, we'll come up with some decisions like, okay, these are the 5 places which I have to visit. So place 1, place 2, place 3, like that something. We may finalize. So our training data kind of thing and all. So then the voting will be there. Then you pass your testing data, the predictions and all will happen. Okay. So this part is like using a decision tree algorithm. So decision tree itself is one algorithm. Here each friend makes a selection of the place he or she has visited so far. So based on those parameters, one place will be suggested kind of thing, right? The second part, after collecting all the recommendations, is the voting. Okay, we'll ask like, okay, we got these 4 places now. I decided final. Out of that, any one I have to select it. So then I'll get into the voting procedure for selecting the best place in the list of recommendation. This whole procedure of getting recommendation from friends and voting comes under the concept of a random forest algorithm. Clear? So what we can understand with these things is basically random forest works with 2 parts. One is the decision tree and another one is the voting. So decision tree itself is one algorithm. Next, random forest is more used for understanding the feature importance. Means it is used in pre-processing stage of multiple projects. Okay, so these are the some points which we can remember with respect to random forest algorithm. So the last one para is there. You can I'll just read it. You can check it out. The collection of decision tree classifiers is also known as a forest. So you get a lot of data, right? So more data, more decisions you are collecting from individual people. So that is called as a forest they are telling. The individual decision trees are generated using a attribute selection indicators such as information of gain ratio. So it's getting into some more deeper about the algorithms. So basically random forest can be used for both the cases like classification related task also and with the regression related task also. So now we'll get into the next algorithm, that is the SVM, support vector machine. So SVM, support vector machine, again it's a type of a supervised machine learning algorithm, and maximum it is used for classification. It can be used for both conditions, classification and regression, but maximum preferred is the type of classification. Okay. The main concept of SVM is to plot each data item as a point of n-dimensional space with the value of each feature being the value of a particular coordinate. So again, you can see that data, right? Here some data points has been assigned. So what it's going to find out is, just a moment. So you can see here, so how the SVM works is it's going to find out some vector points between these data points. Okay. So it's going to draw a line and it's going to find the distance. So here some vector terms and all is used with respect to the data point. So you draw a line kind of thing, which we get some vector supports over there. and how it is assigned with those data points. So we are going to find out those coordinates there. Okay. So one more data set example, that is the iris flower. This is like a very basic data set which is used in many of the algorithm explanations, iris flower data set. So in this data set, we have total 150 data. Okay. And the output class names are there with that flower, like iris. It's a flower type. The flower type like setosa, versicolor, Virginica. So these are the different type of the class, output class of those flower. So you can see those respective class flower images here I mentioned. And here the data, it is having the features of 4 parameters. 4 features are there, the input parameters. These are the 3 output class. Okay. 3 classes is there, and with respect to each class we have data around 50 data. The 4 features are there with iris dataset. One is the sepal length and width. These data are in centimeters, petal length and petal width. So you can see this is called as a sepal, and this is a petal with the flower part. Okay. So the length and width of sepal and length and width of the petal. These are the 4 features or 4 parameters are there with as an input parameter, and output 3 classes are there. So for each class we have a 50 data which is called as an instance. So this is one data set which is used in maximum of the explanations or with the examples. Next, SVM. Again in SVM we get 4 types. One is linear, polynomial, Gaussian, sigmoid. Generally we call it as a kernel. Kernel type we have to mention. If you are not mentioning, again it works with the default one. Okay. So SVC, in our code we mentioned there SVC with the linear kernel. So generally linear kernel concept was used. So 4 types of SVM algorithms are there, which is referred with the word as a kernel. When you read a theoretical explanation about a SVM algorithm, we get a word called as a kernel. So kernel refers with the 4 type of SVM. So that is the linear, polynomial, Gaussian, and sigmoid. So you can just observe this image type. So linear lines we can find here. So polynomial, some curve methods and all has been followed. So this is how the internally to assign the vector points for the data, it's going to work. So by this, I just completed with all the basics of algorithms with respect to supervised machine learning. So we discussed about logistic regression. I have just covered a very simple points for each algorithm. You can consider some 4 to 5 points. I have covered it. One was the logistic regression, then k nearest neighbor, then Gaussian AV bias we discussed. After that, random forest and SVM. These are the 5 algorithms. So in the next session, it's almost 11 o'clock. So now in the next session, we'll be seeing like unsupervised related algorithm. One is the k-mean and the mean shift. So these 2 algorithms are there. So we'll just see this part, k-mean and mean shift algorithm. That is one thing. And I didn't explain about the regression type. The content are there in the first slide. So I'll just open this. So I'll complete this regression type, then we'll get into the next session later. So the first slide which I used from day 1 of my sessions. So all of you can just open that and check it out. Right. In my first slide, the which I used, I missed about explaining about the type of regression. So I'd open the first slide here. So where you find types of machine learning. So when we speak about supervised machine learning, supervised means the output class will be fixed, right? So we'll be having an output class in our data set. So again in supervised we have two types. One is the classification and another one is the regression. So the word regression means it comes with some real value. Real value means the best example we can take like an units, like distance which is told in terms of kilometers, meters and all. Then related to the weight related activities, height, measurements, all these are the units, rupees things, right? So all those things comes under the type of a regression whenever you want to classify anything. So wherever we find more informations related to some numerical values with the units, basically it's a type of a regression. So we can see some points here which I mentioned. So regression is one of the most important statistical machine learning tools. So it is more with the numbers, with the units and also which comes under statistics part. So it may be defined as a parametric technique that allows us to make decision based upon the data, or with the real world allows us to make the predictions based upon the data of learning, the relation between input and output. See, there are other things are same. Since regression is also a type of a supervised machine learning, whatever we saw the points with respect to classification till now, whatever we spoke, everything is same. Only when we tell like it's a type of a regression type of classification which comes under supervised, where we find some standard units. Okay, we can keep in the mind like wherever we find standard units, we can tell like it's a type of a regression. So like here you can see that stock price. So related to stock market, again it comes with some standard units, standard values, right? So again that problem we can take under the type of a regression. Clear? Okay. So I'll continue with the next session now. The 11 o'clock session I'll start now. By 11:30 we'll take a break. Or a break is required now, or I can continue by 11 till 11:30 I can continue. Session break required means I can give some 5 or 10 minutes now, or by 11:30 we can take a break. Okay, means continue or a break. Okay, I'll continue, right? So I'll continue till otherwise I'll complete these two algorithms explanations now. Then we'll take a break so that we can get into the next topic. Once I complete these two algorithms, the present topic will get completed, like a discussion about the algorithm theories. Okay. Now we'll get into the unsupervised machine learning algorithms. So unsupervised means where we don't have the standard output class, right? Output class or a name is not standard. Till now we are not seen any example regarding to unsupervised machine learning. That we'll see in the next level. One more example I have where we'll see the meaning of a unsupervised machine learning part. Okay, so we'll see with an example later. So here in unsupervised machine learning, two algorithms are there. One is the k-mean and another one is the mean shift. So here I had given one link. I'll just open this link in a browser page. Interested members, you also can open it. So whenever we speak with respect to unsupervised machine learning, we use the word called as a clustering. Supervised machine learning, we generally use the word called as a classification. Here we are going to use the word as a clustering, right? So some theoretical statements are there in this, and there is a small animation. So for that reason, I'm opening this link. Yeah, it's here only. My internet is slow. Actually, this animation works much more faster way. Right now, I connected with my mobile. Some Wi-Fi issue happened. I'll see in the break that this works in a faster way. Okay. So initially, you would have seen like here some data points was there. based on those parameters, the data points was moving to these different areas and the clusters were created. Now this is slow. See, the related to those points, the clusters are getting created. Okay, let it take small time. Again, I'll run. So this you can consider like an original data. So all data you have, because we don't know the cluster. Example, you can take with the again with the fruits classification. You don't know the name of those fruits at all. Okay, you have a bag. All the fruits has been jumbled there. Everything is kept inside the bag. So we don't know like how many types of fruits are there. How many types also, quantity count, nothing we know, because the output class is not fixed when you speak about the unsupervised machine learning algorithm. So the first job is, first we have to categorize that. Okay, so you pick up the first fruit, you don't know the name of it, that is the data. Here so many data we have, right? So you know the parameters of it, the features, and also observe it. Based on your observation, you'll create like this is a cluster A. So this belongs to cluster A. Then again you pick up the next data, that is the next fruit, and do some observations. And if you feel that that data belongs to the type you decided first as a cluster A, again you pass it to the cluster A. Again, one more fruit you are going to pick up. You do some observation in that. So this is quite different from the cluster A. So you name it as a cluster B. Again, third next one. So if it is again it is that next data is different from cluster A, cluster B, then you put it on cluster C. So like this we go with the classification. Creating a clusters in unsupervised machine learning. So this is your original data. So after observing some data points over there with the features, all those things, the end result I came up with creating 3 clusters. So these 3 clusters I can tell like 3 classifications, right? So then you apply your supervised machine learning algorithm. You made your own classes now. After that you apply the supervised machine learning algorithm. Okay. So the same image I had copied into my slide from the website. So now we'll see like the points about clustering. So unsupervised machine learning algorithm, K-mean algorithm. First we'll take an example of K-mean. So cluster, the meaning of cluster is a task of dividing a set of observations into subsets called clusters. So we are going to do some observation. Based on that, you are going to create a subsets which are called as a clusters in such a way that observations of the same clusters are similar to one sense and they are dissimilar to the observations of other cluster. Means whatever you observed with those data, so within that cluster it is same and it is different from the another cluster. That's what it means there. In simple words, we can say that the main goal of clustering is to group the data on the basis of similarities and dissimilarities. So observe some similarities over there, observe the features or parameters of the data what you have. So and group it as a cluster 1 with the similar features. Again, you find some other feature similar, that is another cluster group, then another cluster. So like that, n number of clusters will be created. So we can see the example here also in my first slide. In the type of unsupervised machine learning. So here with respect to the cartoon images, see the output class is not labeled at all, right? So we observed some of the features of this data point. So here we have total 7 data. With these 7 data points, I created a 3 cluster. With this is one cluster where some 4 data points are similar. With these 4 data points, this is another cluster which is dissimilar. These 2 data points are totally dissimilar, right? So this is another cluster. Now I created one more cluster. This is another cluster where between these 2 data points there is similarity and it is in another cluster. But this cluster is dissimilar with these 2 clusters. So in that case, I created total 3 clusters where I can represent as a cluster A, cluster B, and cluster C level. Okay. So when you have a data without any class or a label name, those things comes under unsupervised machine learning algorithms. So now we'll get into the k-mean algorithm. So in we understood like what is the meaning of cluster and unsupervised, right? So in that there is one standard algorithm called as a k-mean algorithm. So k-mean algorithm is one of the well-known algorithm for clustering. So maximum it is used. We need to assume the number of clusters are already known. So whenever you are applying a k-mean algorithm, we have to take one k value. Say there is a difference between k-mean and k nearest neighbor, kn. That is different. K-mean is different. Kn is used for classification type supervised machine learning, and k-mean is used for unsupervised machine learning for a clustering purpose. So here k-mean algorithm also, where we have to take the k value before. So whenever you want to start with k-mean concept, we have to take k value. That is the step one. Fix the number of clusters and randomly assign each data point to the cluster. So initially we have to, by observing those data or some method, we have to fix that here the k value will be 5 or a 10 or a 2, 3, means that many clusters will be there. According to that, the data what we are having, start of assigning for the respective clusters. Or in other words, we need to classify our data based on the number of clusters. So first take the k value and then classify your data. So this is one link which I have opened here that I mentioned in the slide. So if you see here, image segmentation is one application. When you have an image, like now you are in front of the table with your computer and all, if you consider this, that is an image. So we have a laptop there. Laptop screen looks in a different format. The keyboard looks in different format. You have a mobile there. If you have kept side to the laptop mobile, or if you are using a mouse, maybe there. You would have kept one water bottle on the lap table. All right. So here now, if you want to classify all these things, you can make it as a different segments by observing those things. So segmentation is one concept in image processing. Again, that is used in different applications. Whenever you want to go with image segmentation, that task is handled in the format of a unsupervised machine learning algorithm with respect to some k-mean clustering method. Clear? So segmentation is one example. So similar way, some other examples and all has been mentioned here, like news article. Whenever you get a news, you classify into some clusters and check it out. It belongs to which category of news and all. So these are some of the examples here. Few points has been mentioned. This is a small animation, but this is not working. So this is the beginning when you saw that all with the black color dots, right? So now based on some data points, assuming 3 clusters will be there, these data are grouping into the respective clusters. So this is the animation which runs. So you can observe it. So initially all the data points will be in a black color. Then we are assigning k-mean value as 3. So 3 colors there. Then based on those analysis, the data points are assigned with the individual colors. A simple animation to understand the theory about k-mean cluster. Okay, so we will understand this thing again with one example later. One sample code I'll run, so we will try to understand it much better way. So there is one more algorithm which comes under unsupervised machine learning, that is a mean shift algorithm. Okay, so mean shift also works with us, is used again for unsupervised for clustering purpose. It's another algorithm. It's another popular and powerful clustering algorithm. So here any assumptions are not done. In k-mean, k is the value which we assume initially that by observing the data points, we assume like here there are some 3 clusters, 5 clusters, and start of assigning your data points with respect to those clusters, right? Like example, you have a bag full of fruits. Just by observing something, you tell like, okay, here there may be 4 types of fruits. So then each data point you assign like type 1, type 2, type 3, that you are going to create a clusters. So here in mean shift, there is nothing called that kind of assumption. It does not make any assumptions, hence it's a non-parametric algorithm. It is also called hierarchical clustering or a mean shift cluster. So it works with some mean shift method. So that's why it is called like that. So basic step, first of all, we need to start with the data points assigned to a cluster of their own. So some data points of their own clusters, we have to start something like that, it is telling. It computes the centroid method, some centroid methods it's going to work. So some method for another algorithm, like k-mean works with a few points there, start from here and it goes like this. So same way mean shift goes with some more points, algorithm points, and it's going to follow that one. By repeating this process, we move closer to the peak of the cluster. So for every cluster, it's going to repeat the process. Means not only this algorithm, all the algorithms, some repeated cycles will be happening internally. It doesn't flow in one flow, and it comes with the conditions. A lot of loopbacks and feedback methods will be applied for every algorithm. So this algorithm try to find out the centroids kind of thing, and when it finds the best centroid, it's going to stop there. So till it finds the best centroid and all, so it will be repeating the cycles. The steps of the algorithms will be repeated multiple times to find out the best centroid and all. So according to that centroid, the clustering will be formed. Okay. So this is with the mean shift. So by this, I completed all the theoretical discussion about the algorithm. So till now, whatever we discussed, any doubts, any clarifications there, you can just coordinate. Any doubts?
KNN you cannot say as a segmentation algorithm, sir. KNN
KNN?
is also doing some sort of k nearest neighboring. So it is not a type of segmentation, sir.
See, you can't tell like a type of segmentation. Again, you're going to make a grouping only, the grouping type only, where you're going to create multiple segments. But the word segmentation we use mainly for image processing. K-mean, see, KNN algorithm is there, no? That we tell for the classification type, right? Means for supervised, when you know that how many segments are there in the image, if you know like there are 3 segments you want to do with the 3 specific class name, if you have, then you can follow that one. But if you don't have any specific class name, that time it comes under the category of unsupervised machine learning, where we can enter into some K-mean algorithm method.
Okay.
Okay. Now, any other doubts, any clarifications is required, you can just coordinate. Okay, now we'll take a break of some 10 minutes. Meanwhile, I'll solve my internet issue also. So I'll just mention here break of 10 minutes. Some few theoretical discussions, and we understood about supervised and machine learning algorithms type also. So now we'll enter into the code part, next code. All of you can see this one, mall segment K-mean clustering. So here there is one data set. All members can just open this data set once. So and the code part also. So this is not like any complete end, like a closed loop kind of code. So in this code, I'm trying to cover some few different types of graphical format. Okay, we'll see at the end like one 3D graph also. So how to make use of different graphical formats and the importance of graphs we'll see, and we'll try to understand a few informations from those graphs. Okay. So here one part I'm giving importance for the graph, And second part, I am taking an example of an unsupervised machine learning algorithm. So how the clusters are created, that we'll see in this code. Yeah. So I'll give a start. Hopefully, like all of you come back right from the break, right? So I'll start now. Right. So this is the data set, mall customer segmentation. So you can observe here few parameters are there, gender, age, annual income, and spending score. But here we don't have anything, something called as an output class, right? So when you find a data set in this format, so these all comes under unsupervised machine learning algorithm because we don't have any standard output class, right? So now this data I have to handle in a format of a clustering. So I have to create the clusters now. By seeing this data, I have to create like the whole data. Now I have to create the customers segmentation. So how many categories of customers I have? So I have to create the clusters like I have 5 types of customers, 3 types of customers. That comes under clustering. So even the image segmentation also, when you have an image, in that image, what we have means you have to segment it, right? So that is also a type of a unsupervised machine learning algorithm. Okay. So here we don't have any output class now. Clear? So that is the data set where we have the parameters of age, gender, annual income, and spending score. Now come to the code part. So all the members can open the code. Mall came in the file name which I mentioned. So I'll execute this code now. So when I executed, we can find a first graph here. So I'll just minimize this. I'll just rearrange my output screen. So the first graph has been opened here. So you can see the visualization. The graph look is quite different, right? So compared to the previous 2 examples, we saw everything with a bar graph. So here now we'll try to understand some more the graphical visualization concepts, the different types of graphs we can generate, that and all we'll see. Okay, first I'll start with the code part now. So machine learning codes or Python code starts with libraries. First, all the basic libraries: NumPy, Pandas, Matplot, and Seaborn. So these 2 are the graphical libraries related to graph generation. Then for machine learning algorithm, scikit-learn library I'm using. So you can find here k-mean clusters. So k-mean algorithm. So k-mean clustering algorithm I am going to use here. So that algorithm name I have defined here. Then related to some 3D graph part, access 3D something library package I'm using. So at the end we'll find one 3D view also that we'll see here, graphical view 3D part. Okay, so the libraries and all importing done. So library part done. Then read CSV. The first step is now we have to take our data, right? So I read my data here. See, this code I'm giving importance for some graph part. I'm not considering other things. So all these are the learning codes, right? So in each code we are trying to learn some new things or different topics. First we saw the full cycle of the machine learning. Then in the second code I explained how to use some more algorithms there, and how to solve the, if you get some accuracy issue, how it can be solved by observing the parameters. That was one concept which I covered, right? Now this is one more machine learning related code, but here we are not concentrating on the end output and all. So I'll just explain how to use k-mean algorithm and all, and we'll see some graphical visualization. Okay. So the first read your data using Pandas library. So I read my data. So the complete data set came inside this variable df. The whatever the data I was having in Excel, everything I took into the variable df. Then df.shape means we are going to get the size of my data, right? So it is having total 5 parameters, 5 columns are there, and 200 rows is there, 200 data we have, right? Then head means it's going to give the first 5 data in the output screen. So you are able to see the first 5 data here. See here dot contents you are not finding because the parameters are only 5 is there. So all we are able to see in a single screen. So there is no dot contents, right? So the first 5 data I'm just seeing in the output screen. Next describe, df.describe. So it's going to give some information about each parameter. So where it's going to give the count. So see this count for all the parameters is 200, right? So all data are present. We don't have like any empty cells. None of the data are empty here, empty cells and all we don't have. Then we can find the minimum. Check out with the age. It's quite easy to understand. So in age we can find like minimum data with the age of 18 we have. Same way maximum age is around 70, right? So minimum age, maximum age in our data we can identify. Same way with your income also. The maximum income is around 135k something, and minimum income is around 15. So spending score, some score has been assigned based on their spending. So the minimum score is 1 and maximum score varies from 1 to 100. So the maximum up to 99 we have. So these all things, what is the minimum, maximum, all the counts are correct or not, we can see in the describe. So mean you can consider like an average out of 200 with all the data. Sorry, the minimum and maximum values here. The average you can consider the meaning of mean. The average age of my data is around 38. The average income is around 60k. The average spending score is around 50. Okay. So some informations we can identify with the describe function. So we understood some information of the data now. Next is df.null dot sum. So when I give null dot sum means it's going to give the total count of the empty cells with respect to each parameter, right? So now everything is 0. So what does it mean? So I don't have any cells empty. All my data is filled. If you see the data set here, so none of the cells are empty. Everywhere it is filled. So we have data over there. Data content is there. Clear? Okay. So that part done. So all these functions we saw in our previous examples also. Now customer ID parameter I don't want to use for my analysis. This ID is not required. This parameter is not required because it is just like serial number. So if I don't want for my analysis, I can drop it using drop function or delete method. In previous code I showed using a delete keyword. So here using df.drop function I am removing this parameter from my analysis. So in my data set, this parameter has been removed now. Okay, fine. So next is the figure. So we are getting into the plot. So here plot figure. So that is the figure size, overall size of this plot. So this is by 8 by 4 kind of thing is there. So if you want to reduce, you can reduce it. The plot title, ages frequency. So you can find like here, title has been mentioned, right? So then access style, the style of that plot is dark something. Then violin plot. This plot is called as a violin plot, like how we know the graphs and all, right? So bar graph. So same way, this is called as a violin plot where I'm passing my parameter age. Related to the age, we are trying to see. Plot show means that the plot has been opened and the code is altered at this point only. Once you close this plot, it will get into the next code. Okay. So I'll just close this. So the next plot you can see like it's quite different, right? So we'll see like different types of plots here. So some color difference you can find here, bar graph similar. So here some ranges has been created in these plots. So similar, the ranges has been seen with different parameters. So this is like some curve and all we are finding, right? So here some k value. This is with the algorithm k mean we are using. So for that, see this is the last plot where you can find some graph. I'm moving it. Okay, I'm selected my mouse point. I'm rotating it, so you can see like a 3D view, right? It is with 3 plane. 2D means 2 plane, right? X and Y plane. So X, Y, Z, 3 plane is there here. So I can rotate in all the, see this plot, if the observation how you have to do, like assuming you have a cube in your hand, we get that cube, right? Game playing a square cube. So square cube is there in your hand. So that cube you can see it in 6 planes, right? In 6 views. So all the 4 side views and 1 top and 1 bottom. So similar way you can move this and you can see it. So each plane, this is the one plane. Now plane 1 you can consider. Then I'm moving to the plane 2. So plane 3. So plane 4 like that. And top plane if you want to see now I'm seeing from the top view, top plane. So similar way, I'm viewing it in a bottom plane. So right from bottom plane also, you can view it. Okay. So this, if you are moving by your hand and observing, it's quite easy to understand the planes and all. So, but this is like a 3D plane. See, I'm stopping in a position where all the 5 clusters we can observe here, right? So later, all of it can run in your system, and you can move this plane. You have to hold the mouse pointer and move the mouse point here using a click button if you are running in your laptop. So clicking your mouse point, if you are moving, then only you can observe the plane rotation. Fine. So I'll run this code from first now. Figure size, if you want to change, see 8 by 4 was there, right? Now I'll make it like 4 by 2 something. It comes small just to change and doing it. So we change the figure size there, running it from first. See, the plot size got reduced, right? So like that you can reduce the plot size. Okay. So now, how to read these figures, we'll see now. Okay, this is called as a violin plot where I'm taking the age reference. See, one thing is whenever you have a graphical presentation, see in industries, when you want to present something, your analysis, all the management teams and all, they can't present these numbers for them, right? So everything goes in a graphical views. So different types of graphs, even the look and feel will be good. Okay, and getting the data from that. So now this is called as a violin plot, the plot name, and this plot content is there in the Seaborn library. See, we are using the Seaborn library from there. So now age, see, you can observe like age by seeing this, how to read this plot. See, we can see that this black color line in middle is there, no? That gives your data information, where you can see the bottom point of it. So it comes like almost below 20 if you do the observation. So that we can tell that is the minimum age data what we have in our data set. So in our data set, we have all the information related to age, right? So what is the minimum age value we have? That you can see here, the bottom point tells below 20. So somewhere around below 20 is the minimum age. And this the top tip of this black line tells like it is with the maximum age, right? So it is almost around 70. This thing we saw in another code line also, where we saw that age related minimum maximum. Any member can reply? See, in the graph, what I am telling you of observing this black line with the minimum age and maximum age, this content we observed with some other code function also, right? Which function it is? Any member? Where we observed the minimum age and minimum value and maximum value of the age as per our data set. In which function we observed that? We saw with the function describe, right? So if you see here in the describe function, when I call describe function for our data set, you can see with the age part, right? So here minimum is 18 and maximum is 70. So what with the numerical format, how I am finding with the describe function, same thing I am finding here with the graphical format also. Okay. So here minimum and maximum we can find out with this black color line. But here one more information what I can find is, see, there is a little bit thickness in this black color line, right? See, this dot is there, no? That is the average age. What is the average age I have in this in my data set? That is coming almost around half of it, somewhere around 35. We can consider the average age, and this little bit thickness we are finding. No, see, more what this black color thickness means is that more of our data resides in the age of maximum of 50 and below and minimum of 30 means we have a data where we have our data where maximum of our data comes in the age segment of 30 to 50. That is what we are going to get the information from this graph. Clear? So this thing I was not supposed to get in that describe function. So in this graphical method, I am able to get one more information like the data what I am having. In this data, the maximum age people information is from 30 to 50. So 30 to 50 age related data I am having. Clear? So any doubts is there, you can just clarify. So this is with the first graph. Okay, and this plot is called as a violin plot. So I'll close this now. So now we can see one more type of graphical visualization. So first we'll see the code part here. So here you can see that. So this is the code portion of this another plot type. So the figure size, plot box and all. So here we are taking the data of a spending score and annual income. So two parameters has been taken in this. So one is with the spending score and annual income, and these kind of data, this type of graphical format is called as a box plot. Okay, so this graphical visualization is called as a box plot. So in a single plot, I'm plotting two parameters information. In violin plot, I plotted only one parameter information. So here I'm plotting two parameter information. See here, I'm using matplotlib also. Matplotlib for this complete frame, the complete graphical visualization. Inside that, the box plot is happening with support of the Seaborn library package, right? So both the packages are used to get a single plot. Here also same thing was done. See the plot, overall plot size, everything was done with the matplotlib support, and the violin plot design was coming with the support of the Seaborn library package. So here also the box plot is drawn with the Seaborn library package. Now we'll try to understand what is there in this. Okay. So similar way what we saw with the violin plot, in the box plot also similar informations are collected. Like here you can see the spending score minimum is around 0, somewhere around 0, and the maximum spending score is around 100, because the score starts from 1 to 100. Okay, it is 1 only, I believe. So 1 to 100. So in that range we have. And this is the average spending score. It is almost coming around 50, and the red color portion is the so what it means is the maximum data what we have, the data what we have, in that data the maximum spending score informations comes from somewhere minimum of around I can consider 35 and maximum of around 70 to 75. So in that range only we are having the spending score. This the red color information, so whatever it is filled with red color, right? So how to read this is the minimum spending score, the data what we have, in that data maximum of the data starts with minimum spending score of around 35 to a maximum of around 70 to 75. Clear? Same way you can check with the annual income also. Feedback link. Okay, right, they'll send by 12:30. The session closes by 12:30. No? Okay. Fine. So this is another plot, a box plot with for the annual income parameter. So here also you can see the minimum is below 20, right? Somewhere around 15 we can consider, because it starts 0 to 20, some 15. The minimum, and max is around 125 to 130 somewhere. Okay, and this is the ratio where the maximum data resides. The maximum data with the annual income resides in the range of somewhere around 40 to 80. The maximum data what we have, in that data with respect to annual income parameter, the data value resides somewhere around 40 to 80. The blue color, what it means. Okay. So now I'll close this. I'll get into the next one here. So there is one parameter called gender with respect to male and female. So now using a bar plot, bar graph. I'm just seeing the gender parameter. So male and female. So related to female. The overall data we were having around 200, right? So in this data set, female data is more. So it is more than 110 around, right? So and with the male data set is around 80 plus 85 and all we can roughly consider. Okay. So this is with the bar graph. So till now whatever I explained, any doubts is there, you can just clarify. So that I'll wait for 2 minutes and I'll continue with the next part. So I covered some 3 graphs now, Weiling graph, then box plot, then bar graph part done. So any doubts is there, you can clarify so that I'll continue with the next part. Okay, no doubts. Okay, so I'll close this. And so next we'll see the next graphical visualization. So this is drawn with respect to customers and with the age part. So here quite changes has been done. See, when you have a data like age or some parameters like temperature, the numbers will be different, right? So now you can't see the graphical views of individual number wise, right? So individual number wise, if you draw means again with the age 20 will be there, age 30, 31, 35. So all the numbers are there. So we have to make a small grouping or to see those data. So here you can observe that. So a small grouping has been done. So right from age less than from 18, we saw minimum is 18, right? So from 18 to 25, it is put it in one group. So same way from 26 to 35, another group, 36 to 45, another group, right? So from 46 to 55, one group, and above 56 is a one more group. So I have categorized into 5 groups now, observing to observe the age content. So individual age wise we can't see, and that is not worth also. So what we are doing here is 5 groups has been created from the range like 18 to 25, 26. So you can see in the graph here. So the grouping has been done using some small ampersand methods. This is the AND method, okay, logical and using these things and all, we have taken the range of it. So greater than, so age greater than 18 and less than or equal to 25. Up to 25 it will come here. So from 26 to less than or equal to 35, that we are assigning into different variables. So I'm segregating it, right? So then I'm taking some X value because I want to mention it in the graph here. So that whatever the format I want should be printed here in the graph, that you can mention here. The same thing has been mentioned. Above 56 is mentioned as 55 plus. Then using a length function, the total count of each group, whatever is there with the values, that has been mentioned here. Taking that one and a plot has been done. Means a small calculations has been done. Then we are passing that data to the plot. Means see in the previous and all what we saw, whatever the data was there in the parameter, means in the Excel, that we are just passing to the graph, right? So here what new thing we are finding is some data to observe in the raw format what you have in your data set, the parameters directly we can't pass to the graph. We have to change it, applying some code, some methods, some logics or thinking. You have to do some changes, then put it into the graph so that it becomes much more meaningful in our reading. Clear? So that changes you can see here the ages and all individual age wise seeing it's based off, it's not so worth. So we have made the ages in a group, writing some small codes and all. Then I'm plotting a graph here. Okay. So all these are simple bar graph methods. So now you can see the graph. By this, what I can understand is we have our data maximum in the range of around 26 to 35, which comes around 60 data I have, right? Okay. So this is one. So I'll close this now. Now the next part. So this step I am repeating for other parameters also. What I did for age, same thing I am doing it for the spending score also. So spending score from 1 to simple different programming methods are followed here from 1 to 20. if you see greater than 1 and less than 20. So spending score varies from 1 to 100, right? So I'm dividing into 5 categories for in step of 20, 1 to 20, 21 to 40, then 40 to 60, 60 to 80, and about 80 to 100 like that. So you can see here. So same method what I did for age related. Now I'm spending score also. Again, that number can be individual, multiple numbers will be there. With single number, no use of analyzing. So that's why I'm making a small group and all. In step of 20, that I have divided into 5 groups now, and that part I'm seeing in the output screen. So you apply a simple logics or simple coding methods, and then you visualize your graph. Okay. So means what I want to convey is it's not like directly whatever your parameters are there, just you pass to the graph. Some conditions are there where we can directly pass and we can see, and some scenarios will be there where we have to change the data content in different form and then pass to the graph so that it gives some meaningful information. So by this we came to know that for the spending score around 40 to 60, we have more data. That data is almost around 75. So more than 70 data out of 200 data, around 70 data comes with a spending score in the range of 40 to 60, right? Okay, so I'll close this now. One more similar step is followed for another data, that is the annual income. So annual income also is changed from 30 0 to 30, 30 to 60. In step of 30, it has been divided. So that also I'm plotting in a graph. So if you see here the annual income part, so again we can observe like around 60 to $90,000 something as mentioned here. So or 30 to 60. So 60 to $90,000 we have maximum data, almost around 80 data. Or if you consider right from $30, so here around 30 65 and here 80. So 140 data I have in the range of 30 to $90. And I have very less data which comes around 120 to $150, 120 to $150,000, right? So you can find that difference. So you'll come to know with based on the income how the data is we have in our data set. So now I'll close this. So till here we saw multiple types of graphical visualizations, right? So any doubts is there, you can just clarify it. So multiple types of graphical visualization part completed. So we made use of a Matplot and Seaborn libraries. So if you go and see those libraries, n number of plotting methods will get over there as per our project requirement. Different plotting methods can be used. Okay. So here some commented points has been mentioned. So I request the members to just read it once. In the code, a few commented lines are there. You can just read it. I'll continue with the next part of this code. So now the next part of this code is like, since we have our data set with respect to unsupervised machine learning, right? So how to create the clusters of our data, that part we'll see here. So we are taking an example of a K-mean clustering algorithm. So K-mean clustering algorithm is there in the scikit-learn library only. We have called this library package in the start of the code. Now we'll see that part of the code now. So here. So now we have, see, K-mean, we saw theory, right, in the previous session. So K-mean algorithm, how it works is initially it will assign some K value. So we have to fix one K value, and according to that, the clusters are created, right? So to get the K value, a small theoretical method is there, one small formula method is there. By checking with that, we can fix what is the K value and all, okay? So here you can find like next I plotted with, so there is a small commented line here. So I'll just read it out. So now we are trying to get the K value, which is used for K-mean clustering. Okay, what should be the K value? Okay. So here within clusters sum of squares, within cluster sum of squares against the number of clusters to figure out the optimal number of clusters value. WSS measures sum of distance of observation from their clusters centroids. So there is one method which we have to follow it to find out the K value here. Calculate the within cluster sum of squared errors for different value of K and choose the K for which WSS first starts of dimension. So there is a small theory for this thing. Okay, so I'll just brief like here this last point you can observe the optimal K value is found to be 5 using the elbow method. So there is one method called elbow method, a small formula method they are telling we have to follow that. So these steps and all we can get it in the internet. So what I'm doing is we are taking a range of K value. K value we are assuming like it can be from 1 to 11. Okay. So that range of K value is checked with our data set now. Clear? So you can see here the range of K value we are assuming like it can be from 1 to lot of network issue today. Okay. My voice is not clear. Huh? Any problem you are facing?
Clear, sir.
Clear. Okay, fine. Okay, so what we are doing in this step is see to apply the K-mean clustering. First, we have to get the K value. So to get that K value for our data, we are taking a range of K value and we are passing it. So the K value we are assuming it has to we have to start from 1 and it can be maximum of 11. So that is the for K-mean clustering, one by one we are passing. See, this is the algorithm K-mean. Initially, the K value 1 will be passed and fit. So when fit algorithm we call, we have to pass our training data, right? So here I'm not splitting any my data set as training, testing and all because I'm not going with any final conclusions. Just we are observing few points in this code. So whenever you call a fit function, we have to pass our training data. So using all my data is there in this df variable, right? ilog is a function. So using ilog function from row from the parameter 1 to till end. Here the number is not mentioned, is till end. Okay. So all the parameters I am passing as a training data to the K-mean function now. Okay, K-mean algorithm. So where I am telling that K value is 1. Okay. So passing that to the algorithm. So that thing, the analysis and all, everything is stored in this reference variable here. Clear? So this for loop will repeat from 1 to 11. So after that, whatever that analysis was done, that I am printing on a output screen in a graphical format. You can see that so based on the K value from 1 to 11 means up to 10 it works. So from 1 to 10, some WSS. So the meaning of WSS is mentioned here. Some of the squares, clusters, some formula method. So a graph has been assigned here. So this graph you can think in the format of our hand portion. So the elbow here we can see like using an elbow method. whatever you get as a center, the corner of your hand, if you think the hand part, if you consider your hand when you are lifting it, the elbows, center elbow portion, here it is coming as a value 5. Okay, so that is considered as a K value as a 5 as per our data set. Okay, so I'll just repeat the whole thing what we are doing here. Our data set is a with it's a type of a unsupervised machine learning. Means we don't have any output class here. See, this code till now what we discussed, that was with some graphical visualization, different graphical method I explained. Now taking an example of unsupervised machine learning algorithm, here we are trying to use a k-mean. So k-mean clustering, how it works is initially you have to assign the k value, then you start off processing it, right? Okay, to get the k value, there is one small theory, one small method is there. So where you have to pass your data, assuming the k value in some range for the k-mean function. So the range I have taken from 1 to 11. So the for loop, this is the maximum condition and this is the minimum value. So up to 10, it is passed. All my data I am passing to the k-mean and a graph is plotted. So this graph to analyze, they are explaining in the format of an elbow method where the joint, if you consider your hand portion, the center joint elbow. So it comes around here. That is the value 5. So that 5 is the outcome of this method. Now 5 is considered as a cluster. 5 clusters as per our data. We have to consider there are 5 clusters. Okay. So that has been finalized. Now I'll close this graph. So once I close this graph, we are coming with the final output. So in this final output, taking the k-mean value as a 5 value here, because we are considering the 5 clusters. So considering our data, so I'm drawing the plot here. Okay. So this plot here, it's a 3D plot. Okay. So to analyze this plot, you have to consider like in your hand, you have that square cube, the game cube, square cube 1. So when you consider the cube, it is of 6 plane, right? When we tell a 3D plot, it comes with 3 plane. So the 3 plane, which all parameters has been considered, it is mentioned here, like annual income, age, and spending score. Using this 3 plane, a 3D plot has been drawn. So if you want to observe any data in a 3D plot method, so how to draw it, that I am covering here. Okay. So now our data was classified into 5 clusters, right? So you can find that 5 clusters with 5 different color. So to observe this 3D plot, consider a cube, square cube in your hand, where it comes with 4 side plane and 1 top plane and 1 bottom plane. So in that format, you can rotate this 3D plot to observe. Clear? Okay. So all members can check this thing in your system also. You can observe this 3D plot. So by this, I am completing this code also. So now we completed about all the algorithms, some one example with multiple plotting methods and with a taking a data set example of a unsupervised machine learning. Clear? So if any doubts is there, all the members can just clarify your doubts. Now we'll take a lunch break. Meanwhile, any doubts is there, you can clarify. We'll take a lunch break, and again I'll continue my session by 2 o'clock with the next topic of a neural network. Okay. So now we'll enter into the neural network topic in the afternoon session. So meanwhile, any doubts is there, you can clarify.